Today we're going to be looking at the notes worksheet entitled Verifying Trigonometric Identities Day 3, and this lesson just represents an opportunity for us to get a little more practice dealing with these identities that we've been exploring over the last couple days. So we're going to do just 4 examples here, and we're really starting to get into the more difficult ones. So walk yourself through with me as we go through this process together, and as I do a step, make sure you understand where that step is coming from, and maybe see if you can work a step ahead of me on occasion, pause the video, see if you can figure out for yourself where it's leading and so forth. So we'll go ahead and get started right away here on example 1, and it looks like I have an identity equation that relates 4 out of our 6 trigonometric functions. So I have cosecant in here, I have cotangent, I have cosine, and that whole expression on the left-hand side is actually the same as just secant of x. So let's see what we want to do here and see if we can make that left side equivalent to the right side. So remember, work vertically on your paper if you would. Hopefully I left you enough room to pull this off. So let's give it a try, everyone. I don't see too much in terms of algebraically. There's not much I can do with this as a denominator with this stuff here. I just see some very basic identities coming to the forefront. And so I'm going to create some fractions here within the fractions. As I had mentioned, this kind of comes up with dealing with these types of equations. So as the way I see it, I see the cosecant as 1 over sine. And remember, I can't just bring this to the bottom. This doesn't just become sine down on the bottom because of that plus right here. These two are kind of tied together here. So that's all I can do with that. And then algebraically, the creation of this compound fraction is really my only first step. So I've been doing this when I see a compound fraction. I just like the symmetrical aspect of it. But essentially what I'm going to have to do here is sort of simplify that and see algebraically where it leads us, and then maybe if an identity pops up, we'll go ahead and apply it. But I just have a feeling that most of this will be algebraic in nature. All right, well, let's give it a try here. If you remember correctly, the way we've been referring to these is basically that we want to go ahead and get rid of the denominators by doing the LCD. 4 denominators, 1, 2, 3, and 4. Hope everybody's cool with the fact that the common denominator is going to be sine of x. So I'm going to go ahead and write in sine of x there and there. And remember what we want to do, everyone. We want to go 1, 2, 3, 4 different distributions there. And what should happen is these 2 denominators right here in particular, because those are the ones that are our concern, should cancel out. So let's see what does unfold here. Sine of x times 1 is definitely just sine of x. So there's the first time. Sine of x times 1 over sine of x. Well, again, everyone, sine of x's would cancel. 1 on top, 1 on bottom. So I'm getting this piece right here. Okay. Now down on the bottom, let's see, sine of x times cosine of x over sine of x. See these cancel, everybody. 1 on top, 1 on bottom. And so I get this piece right here. And then one more time, sine of x times cosine of x. Nothing cancels, everybody, so that's as good as it's going to get. All right. Now again, it looks a little better. And now we've talked about this, that it's good to put everything in terms of sine and cosine. We did that here initially and then simplified it. And so we no longer have the cosecant part or the cotangent part. Now we just have to figure out what's going on. And as I said, I really don't see any identities unfolding. There's not much I can do with this. So let's see what would happen algebraically. Now sine of x plus 1 we can't touch. But I'm hoping everybody is looking at that denominator and thinking about factoring this. I think that's our technique that's going to allow this to pay off. And remember, guys, we're looking for secant of x. So you know that cosine has to be on the bottom. And I have it, but I need it to come out as a factor. And so I think that's what's going to happen here, everyone. So the top stays, everybody. Cosine comes out on the bottom. And when cosine comes out on the bottom, there it is. You see what popped up, which you knew had to happen because this is not part of the right-hand side of the equation. And so as a result, that cancels out with that. I'm going to rewrite it one more time. If you didn't write this next step here, that's all right. but I had a little room, so I figured I would. And then, as you can see, everyone, 1 over cosine of x is secant of x. Just humor me if you would and bring that on down at that point. I just do that little check mark as just sort of that's the verification, but you don't have to do that if you don't want to. So remember how these play out, everybody. Basically, this is just the answer in the back of the book. That's the analogy that I would use. That is just like the answer in the back, and you're just trying to get to that answer. And we did. There it is. All right, so example 1, a good one there. I think that's a nice medium to difficult problem. You have fractions within fractions. It's more algebraic in nature than recognizing identities, but there's some good skills in there. Okay, let's go get 2, everybody. All right, so this is a good one. All in sine, it looks like, on the left-hand side. So this fraction and this fraction equal to 4 tangent secant. So I would certainly encourage, pause, try to do it on your own, come on back, see how you did, or do it while I'm doing it. Your call on this. Obviously, you've got a lot of control in how this plays out. Okay, well, the first thing I see, of course, working with this left-hand side is it's 2 fractions, and then over here, there's no minus, there's no fraction, nothing along those lines. So something tells me it's time to put this together. Again, I don't see an identity, so it looks like, at least initially, we're going to have to go ahead and create this fraction here. So I'm getting 1 minus sine of x and 1 plus sine of x down on the bottom. It'll be up to you to determine if we want to multiply that through or not. I'm hoping everybody can envision this as a 1 minus sine squared. If we did, that might benefit us. That might be something we would look at. But for right now, I'll leave it. And then you have to decide, here's the key, guys, when you combine those fractions together, how did you change the denominator? Then you have to change the numerator the same way. So I'm going to do this hopefully in a very formal way for you. If you can shortcut it a little bit, then that's great. So it looks like I multiplied this by 1 plus sine of x, here it is, in order to make this denominator equivalent to this denominator. And so what I'm going to have to do is the same thing on top. So 1 plus sine of x, 1 plus sine of x. All right, now my minus. I'm going to have to stretch that out a little bit there. Same thing with this one. How did I change the denominator? Original to the new and improved. It looks like I multiplied this one by 1 minus sine of x. There it is. And so I'm going to have to multiply the numerator by 1 minus sine of x. All right, good. Now you can see it's really just some good algebra just intertwined with all of these trigonometric expressions. We just have to kind of work with it. I would probably argue you want to FOIL, and you want to FOIL, then deal with the subtraction. So I'm hoping you guys would see this, and I'll leave it up to you. I've got a 1 times 1, which is 1. Outside and inside, everybody, would give me 2 sine of x. And the last, sine times sine, would be sine squared. All right, now careful with minus. Been saying that now for a long time, dealing with an operation like this. Just be very careful with subtraction because it's going to be minus everything we see in the parentheses here. And so I would repeat the process, of course, and I would get 1. And here I would get minus 2 sine of x, outside and inside there, and then plus sine squared of x. Okay, good. And then I'm going to go ahead and take a look at that bottom. It's just too tempting because 1 minus sine squared is something we see quite a bit, and it is something we might go ahead and replace using an identity. Okay, well, let's see where we're at this stage. All I did was kind of combine those together. I probably have one more step in this process here in terms of let's deal with the numerator now. And, I see a 4. We needed a 4 there. And tangent and secant. All right, so let's see what's going to unfold here. I see everybody as a 1 minus 1. Those are going to cancel. Sine squared and sine squared, those are going to cancel again because the minus distributes through. And here I'm hoping you see it. I have a 2 sine of x minus a negative 2 sine of x. Oh, everybody, this looks great. That's 4 sine of x's. And I needed it. I needed that 4, and it popped up. That's great. Now look at the other side, everybody. And this is where it's nice to see a step or two ahead so you can go ahead and plan accordingly. But basically, tangent is sine over cosine, and secant is 1 over cosine, right? So I have a sine over cosine and a 1 over cosine. So I have a couple factors of cosine on the bottom. And do you see here, everyone, here's 1 minus sine squared of x. Is there a way to create a couple factors of cosine with an identity? Absolutely. And so everyone, of course, 1 minus sine squared is cosine squared. And that's looking great. Now, at this stage, I think we have it. I would like to be a little more visual with this. I have the factor of 4. It's almost like a 4 over 1. And you don't have to write this on your paper. I'm just kind of thinking like that. 4 is like that. So I have my 4. And in times, I basically have sine over cosine. And because these are all factors, I can kind of split it up however I want. And then something like that. I'm hoping you're okay with that piece. Sine over cosine, and then the extra factor of cosine would just be like a 1 over cosine. So this, I'm hoping you understand, is also really this, which allows the right-hand side to now take over. And so there it is. 4 tangent of x, secant of x, and we have our winner. I'm bringing it down, and that's a great one. So there really only was one identity into the mix. Well, a couple, I guess. But this, to me, was the big one. Changing that to cosine squared. I've talked about that now for a good portion of time where that does come out. And in here, just working with the algebra, manipulating the expressions. That looks wonderful. All right. 2 good practice problems under our belts, everybody. Let's get a third one taken care of, and then we'll deal with number 4 there in just a little bit. Yikes, number 3. It's huge. Let's see, what do we have here? I have 4 out of the 6 related together here in this relationship. So I have a cotangent down here, a tangent down here, a few sines, other side, just sine and cosine. Interesting. All right. Well, again, we're going to have to play it out here. I definitely see we're going to have to combine things together. It's up to you what you want to do here. I'm kind of looking at this from one lens. You might be seeing it through a different lens. As I said, as long as you can get it to work, there can be multiple paths to these. I'm looking at this as 2 separate ones. I might not be totally correct on that, but I'm seeing this as 2 separate fractions that I might want to deal with first and then put it together. I'm just looking at a common denominator of this, and it's kind of scaring me a little bit. So here's what I'm thinking. And again, if you want to pursue a different path with this, that's totally fine. But I'm getting a sine of x and then 1 minus. I'm going to go cosine over sine and just see what happens. Now again, I like doing this over 1 when I create compound fractions there. You certainly do not have to by any means. And then over here, same thing. Again, just kind of thinking out loud with this. How about a sine over cosine? Something like that. All right, as I said, not sure how it's going to progress, and that's the beauty of these problems. All you can do maybe is take a little risk, and if it works, great. If it doesn't work, well, kind of back to the drawing board. Well, as I said, I'm going to treat each one independently. Here's a compound fraction, and here's a compound fraction. I'm going to just go like this for a second and go like this for a second and see what unfolds. So I'm going to go sine of x on this. I'm hoping you all see the LCD, 1, 2, 3. It's going to be sine. And hopefully now you're getting better at this. This is sine of x, sine squared of x, excuse me. And then down here as well, sine of x, distributed in. And I get sine of x minus cosine of x. Okay, interesting. And then a minus. Let's see. All right, so now, everyone, I'm going to deal with this one. How about a cosine of x as the common denominator? Okay, so let's distribute. Once, I get cosine squared of x. Twice, and I get sine of x. Fascinating. Minus cosine of x. So this is what happened when I did it. And I got something along those lines right here. Okay. Good. Now, if you notice, what I've done is I have created two fractions. It's fortunate, I guess, for our purposes here, that these two fractions that we're going to combine with subtraction momentarily, do you see that they do have the same denominator? And so does that allow us to put these two together pretty quickly just using that common denominator? Yeah, that's good. And now all I have to do is combine the numerators appropriately, and that is just sine squared minus cosine squared. Okay. Well, a couple things to note with this. So I see this last step as one that you maybe would not intuitively see. So I'll make you aware of that momentarily. But I guess I would just say one thing first. If this was a plus, everybody, without question, if it was a plus, you would immediately recognize this identity as sine squared plus cosine squared. It would be 1, and you would go from there. Obviously, guys, it's not a plus, it is a minus, and so there is nothing at this stage that allows us to kind of do that and make anything occur. So here's what I would say. Look at the other side of the equation. You do see there's no fraction, so something tells me that we would have to eliminate that denominator that you see down here, guys. This has to go, because as you can see, it's not on the other side of the equation, so that has to go. What is one of the only ways that really allows us to cancel this out? Well, the only way that I can see just from looking at this right here is if this is also a factor in the numerator. So now let's look at the top, everybody. Does it at least look familiar to some expressions you've seen in the past? Again, it's trig-oriented, so that might throw you off. But I'm seeing this, everybody, just to get this moving for you, as a difference of two perfect squares. And if it's a difference of two perfect squares, that does allow us to factor it. And how does it factor, everybody? Well, sine times sine is sine squared. Cosine times cosine is cosine squared. If you remember, of course, no middle term, so plus and minus. Intriguing. And then this comes up right here. And everybody, there it is. That is a common factor with that. And so, again, wasn't sure how that was going to play out originally, but it just sort of intuitively and naturally gravitated towards this piece where I can combine them together. And so as a result, that's it right there. So you do not see this very often. Let me be kind of clear on that, where a difference of two squares kind of pops up. But I do like the concept of looking at the other side of the equation, realizing what you need, and then also realizing what you have in order to get there. I knew I had to get rid of this. There's just no way around it. And really the only way to get rid of it is if it's also on the top of this fraction. And so the way to create that is by seeing if you can factor it and make that factor appear. And it did. All right. Wonderful. Well, last one. This is a rare exception to these. You probably won't use this very often at all, but it is just intriguing to see. You have seen the notion of a conjugate before. If you remember in probably Algebra 2, rationalizing denominators, you looked at the concept of a conjugate. In Pre-Calc 1, when we did division with complex numbers, we actually looked at the concept of a conjugate. And so here's just, it's a little algebraic trick. That's basically what a conjugate is. So I'm going to just sort of show you through this step here, how this plays out. And then after I show it to you, maybe you can kind of run with it and finish up this. I like this one. This is an interesting one. Cosine over 1 plus sine is actually the same as 1 minus sine over cosine. Well, here's how it works with that idea of a conjugate. So what we're going to do is take a look at this. And, you know, if I gave this to you blind, you would look at that expression and be like, well, what can I do? There's no algebra. There's no identity. There's really nothing to do. So I guess the bottom line here is we're going to have to rely on this little trick to change things up. And the notion is this fraction as it is, again, is not very user-friendly. There's not much I can do with it. But by changing it, and remember, what I want to do is change the look of the fraction, not the value of the fraction, maybe something pops up essentially. And so, long story short here, 1 plus sine of x has a conjugate of 1 minus sine of x. And so what I'm going to do, and you can almost see, again, I kind of told you where it was headed, I basically sort of alluded to the fact that, hey, look, you do need a 1 minus sine x on the other side of the equation. So how can I create a 1 minus sine x if there's just no other option out there? Well, I could just multiply the top by 1 minus sine of x. And if I do that, well, then I have to compensate by doing it on the bottom. And it just so happens that's the conjugate of the bottom. So what unfolds when you do that, of course, is this. And you do want to leave this in factored form, by the way. Now, here's where I would ask you to take over. Since I kind of gave you that first step, what would you do with that denominator? And again, hopefully just the light goes on, everybody. 1 minus sine squared. If you look at what needs to be on the bottom, it just kind of gets you thinking in the right direction. But you all hopefully do know that 1 minus sine squared is cosine squared. Alrighty, that's good. Now you can shortcut this a touch. I do see the right-hand side now appearing. So 1 factor of cosine on top with 1 factor of those cosine squared. So 1 of the 2 factors of cosine down on the bottom, I should say. And then as a result, there it is. And that's it. So again, it really is a very rare occurrence. It's the, hey, there is nothing else we can do moment. And so what we do is we just kind of change the fraction by what's on the other side. And if it's the conjugate, it just plays out. That's all. Okay. Hey, just one thing that gets lost in the shuffle here. And I'm going to just bring my calculator up for a moment. And then we'll kind of wrap this on up. Basically, remember the idea of an identity is the notion that for this right here, if I put any number in for x, it's equivalent to this side over here with that same number. So this expression is equivalent for this for any real number. And so I don't know what this graph is going to look like. I'm curious myself, but I'm going to go ahead and just type in cosine of x and divided by, and then I'm going to just do 1 plus sine of x. So just, drop the pencil for a sec. Just take a quick peek up here. But something like that right there. And I'm going to zoom trig this and just see what the graph would look like. Yeah, interesting. So something like that. Now again, the reality is, with all of these identities, is that the other side of the equation is the exact same. So cosine over 1 plus sine is identical to 1 minus sine, let me get that in there for you, and then divided by cosine of x. And so when I go ahead and hit graph again, nothing should change because all the real numbers that worked for this also work for this. And so when I hit graph, oh, interesting, the asymptotes popped up. Oh, because of this piece right here. And that's why. But the graph is still identical. So it's just kind of intriguing that really the left-hand side is equal to the right-hand side as a result. Okay. Hey, a nice short lesson today, just getting a little more practice. I'm sure that I've put in some time for you. I've scheduled some time into the calendar for you to get some practice on your own. Work with other people, brainstorm some ideas, help each other out. Definitely, just the practice and experience makes all the difference with these problems. So please let me know if you have any questions whatsoever. And of course, I certainly appreciate you listening with this.